Identify the values of the variable for which each radical is defined, then simplify. In this question, I'm going to take out my highlighter, maybe, yes. It's asking us for where it's defined, and it's asking us to simplify. It's actually asking us to do two things. It's really important when you read a question or reread a question that you recognize when they ask you to do more than one thing. Because sometimes we get excited and we just do one thing and then we move on. And have you ever done that on a test where you're like, oh, I just didn't read that part? And you get, oh, I knew that answer, I just didn't read it.
I missed an entire half of a science test doing that one time.
Oh. So that's super frustrating, right? So in math, I'd say very important when you're done a question to reread it. If you like highlighting, like I highlighted, there's two things I need to do. So when I get to part A, I'm like, okay, I have to do where it's defined. I'm going to do that first. And then I'm going to have to simplify. And I remember from yesterday's class that simplifying involves writing as a mixed radical in lowest terms and then combining things. So first of all, define. We learned that you cannot square root, fourth root, sixth root, any even root of a negative. So I have square roots here. So I know that I can't square root a negative. Can you see that if A is negative, that's bad? If A is positive, it's good. How do I write positive numbers and also 0 is fine? I would say it's defined when A is bigger than or equal to 0. Then these are like terms. 6 of them plus 5 of them minus 11 of them. It all goes away. You get 0. If you write nothing, you would still lose marks. You have to write 0. Even though it all goes away, we have to write 0. Okay, part B. Part B, where is it defined? This is interesting because now there's two variables. There's an A and a B. We have to decide if either of them cause problems and what those problems might be. Again, I have square roots. It cannot be negative inside. Can you see that the A squared will always be positive? You take a number and you square it, it's always positive already. It doesn't change. It won't affect things. But B could be a problem. If B is positive, it's good. If B is negative, then I'll have a negative inside. So I would say for the A value, it doesn't matter. But the B value has to be bigger than or equal to 0. Next, this step in purple, I'm going to write down, but I'm going to tell you that if you would like, it's optional. Okay? Because some people can see right away that 50 is 25 times 2. And that means you can pull a 5 out in front. I'm going to take the extra step and write 25 times 2 times A squared times B minus, and the 8 I'm going to break up into 4 times 2 times A squared times B. But if you can see that it's 25 times 2, and you can say, I know the square root of 25 is 5. I know the square root of A squared is absolute value of A. Tempting to just write, that's maybe like a reminder. That's where those absolute values come in. And then the square, I would be left with a 2 and a B. Minus the square root of 4, out comes a 2. The square root of A would be absolute A. And I'm left with square root of 2B. So the way this was originally, you can't combine anything because they're not like terms. But now, when I look at all of my variables and all of my radicals, inside this orange box is identical in both of them. And it has to be identical right down to the absolute value bars and the indices and the inside, the radicand. I have 5 of them. I minus 2 of them. I would end up with 3 of them. And I have my final answer. C. Oh, C is cube roots. It's an odd one. Odd ones are so nice, you don't have to think at all. They can be anything, doesn't matter. So both the P and the Q can be anything. I'll just rewrite the question here. We had the cube root of 27 P cubed Q. And then it was plus 8 cube root of P cubed Q. I don't even have to do the purple step because 27 is a perfect cube. I can pull out a 3. How many exponents do I need to pull out something with a cube root? I need 3 of them. I have P cubed. Every 3, when you cube root it, out would come a P. No absolute values are necessary because it is an odd number. Oh. And what am I left with inside? I'm left with still a cube root of Q. Plus, here, I can pull out the P. And I'm still left with a cube root of Q. When I look at all my variables and all of my radicals and everything, they are like terms. I have 3 orange boxes plus 8 orange boxes would give me 11. 11 P cube roots of Q. So if it's an odd index, defined as super easy. It's only if it's an even, a square root, a fourth root, that you have to worry about the absolute value, and you have to worry about where it's defined. Questions you can circle for this one are 5 and 7.